Hello everyone, this is Muhammad Asad Ali and I teach mathematics at the International School. In today's video, we will learn about normal distribution. So before starting about normal distribution, let's start with an example. So a sample of 10,000 adult males gave rise to the following histogram. Suppose you have collected the height of 10,000 people, 10,000 males, and when you make the histogram of the data, you get this shape. And most probably you will always get sort of this shape when you collect the data, because you can see that people with greater height are very less and in number, and people with very short height are also less in the number. Most of the people are between 164 centimeter to 180 centimeter, and most probably you will find that 172 is the ideal height of a male. So if you notice that the histogram is symmetrical and bell shaped, so this is the characteristic of shape of normal distribution. So if we were to draw a smooth curve through the midpoints of the bars in the histogram of these heights, it would have a shape like this one. Suppose if I want to make midpoints of each histogram and join them, so I will get a symmetrical curve, a bell-shaped curve. So this rises to the basis of normal distribution. So normal distribution is appropriate model for many common continuous distributions. Continuous distribution is a distribution that has random variable which is continuous. For example, a continuous variable is a variable that can have any value on the number line, whereas discrete variable is variable just like 0, 1, 2, means it's always an integer. But when we talk about continuous distribution, continuous variable, it is always it can be a whole number, it can be a decimal, just like it can be 1.1, 1.2, 1.3. So discrete variable is usually the result of counting, and continuous variable is usually the result of measurement. So measurements are always found in continued proportion. We can say that the measurement can never be exactly 5 meter, it may be 5.001 meter, it may be 5 meter and 1 centimeter, and 5 meter and maybe 5 meters and 0.001 millimeters. So even if you see that two bars of same height are same, just like we say 5 meters and 5 meters, but we measure them accurately, as accurate as possible, we will find that both are not exactly same. One may be 5 meter and second may be 5 meter and 0.003 millimeter. So continuous distribution is normally ideal for situations in which we find the masses of newborn babies, and the IQs of school students, and the hand span of adult females, and the height of plants growing in the field, and so on. So the normal curve is symmetrical, as we discussed earlier, but the exact shape is governed by two parameters, that is mean and standard deviation. So mean always lie in the middle, and standard deviation is usually represented by sigma. In normal distribution, it's always represented by sigma. So if x follows a normal distribution with mean and variance, so we present this information in this way: normal distribution, and in bracket we write the parameters like mean and variance. So there are some properties of a normal distribution. The first property is that if you look at the bell-shaped curve, 68% of the data lies within mean minus 1 standard deviation and mean plus 1 standard deviation. Suppose if you take the height of people, then, or suppose if you take the height of people, okay, 172, and the standard deviation is, let's say, 10. So 68% of the data, if it is normally distributed, so 68% of the data will lie between 172 plus 10, which is 182, and 172 minus 10, which is 162. So we say that 68% of heights are between 162 and 182. And the other property is 95% of the data lies within mean minus 2 standard deviation and mean plus 2 standard deviation. It's 95%. And the third property is that 99.7% lies between mean plus minus 3 standard deviation. That means mean minus 3 standard deviation and mean plus 3 standard deviation. So this is the property. So as a normal distribution always represent continuous data, it only makes sense to find the probability that x takes a value in a particular interval. For example, we could find, let's say, probability that the normal variable x is greater than or equal to 20. That means, suppose if the mean is 50, so x will be either 20 or greater than 20, like this way. And it also makes sense if we find probability between 5 and 9, and we can also find probability that if suppose if the question says find the probability that x has exact value of 19, so we know that continuous variable cannot have exact value, so we can write this in interval that probability that x will lie between 18.5 and 19.5, or even you can get more precise answer if you write 18.99 to 19.01. This is also fine. So probabilities correspond to the area under the normal distribution curve. So there is no simple formula that can be used to find the probabilities. So instead the probabilities are found from tables and graphical calculators. So we have developed some distribution tables like this one. So here you can see this is for variable x that follows normal distribution with mean 0 and standard deviation 1. The random variable that follows normal distribution is usually represented by z instead of x. So z is 0.00, so we can say that 50%, the probability that the z has a value 0 is 50%, 0 or less. And we can say that the probability that, suppose if you want to find the probability that z is less than or equal to 0.54, so you will see 0.5 here and 0. This is basically the second decimal place, so 0.54. So the probability that z will be less than or equal to 0.54, it's 0.7054. So in other words, we can say this is the cumulative probability. So there is no simple formula that can be used to find probabilities. So instead, the probabilities are found from tables or graphical calculators. So let's suppose we have a distribution in which the mean is 0 and the standard deviation and variance are both 1. So usually this distribution is not only normal distribution, but we say that this distribution having mean 0 and standard deviation 1 is standard normal distribution. Because in real life we can have if we are studying any variable that can have any mean and any variance, and but usually if it is normally distributed it will have the same shape. But if a variable is standard normal distributed, so we say that this is the mean will be 0 and standard deviation is 1, and this is that random variable is usually represented by z instead of x. Most of the books you will find a table that is a z table or z table. That table is basically showing the cumulative probabilities of random variable z with mean 0 and standard deviation 1 that is normally distributed to the certain point. Suppose that may be 0.2. So the probability that a standard normal variable having value 0.2 or less, so that area is basically the probability that z is less than or equal to 0.2. So let's study how to read that table. So we have a standard normal distribution table here, or in other words, we can say if z follows normal distribution with mean 0 and standard deviation of 1, then the cumulative probabilities are given here. Suppose if you want to find probability that z is less than or equal to 0.54, so you can find it by adding 0.5 on the left side, and this 4 is the hundredth value, so this 0.5 and 0.004 makes 0.54. so probability that z is less than or equal to 0.54 is the intersection of these rows and columns, that is 0.7054. Let's have another example. Suppose if you want to find probability that z is greater than 0.6, so this is 0.6. So 0.60, that is 0.7257, but this always shows us the cumulative frequency less than or equal to. So if here we want to find probability that z is greater than 0.6, so we can use the property of the distribution, any probability distribution, that is, that property is that probability that x is greater than a is basically 1 minus probability that x is less than or equal to a. So if we have to find probability that z is greater than 0.6, that is actually 1 minus probability that z is less than or equal to 0.6. So for 0.6, we have 0.7257, and when we subtract them, we get 0.2743. Let's have another example. Suppose if you want to find out probability in intervals, that probability that z will be between 0.25 and 0.78. So if we make the diagram of the situation, mean is 0, that lies in the center, that z is between 0.25, so 0.25 will be here, 0.25 to 0.78. So we have to find this probability. So if you want to find this probability, you just need to find out probability that z is less than or equal to 0.78 and probability that z is less than or equal to 0.25, and when you subtract these two areas, you will be left with this shaded area. So in other words, we can say the probability that z lies between 0.25 and 0.78 is same as probability that z lies before 0.78 minus probability that z is less than or equal to 0.25. So using the z table, 0.7 and 8 at the top, 0.7 and 8 at the top, you see the intersection is 0.7823 minus probability that z is less than 0.25, so 0.2 and 5 on the top, so it's 0.5987. So when you subtract these two values, you get 0.1836. Or if you have a graphical display calculator, you can just use the GDC function of a normal CDF and enter the mean 0 is standard deviation 1, and for this one lower limit is 0.25 and upper limit is 0.78. Let's have another example. Suppose if we want to find out probability that z is greater than negative 0.3. So here you can see we have only positive values. So the property of normal distribution curve is that it is symmetrical. So if we have 0 here and if it is 0.3 here, so negative 0.3 will be at the same distance from it. So if you have to find out this area, this will be same as this area because these are symmetrical. So if you want to find probability that z is greater than negative 0.3, means this much, this area, so you can alternately find area of the other side. So that is probability that z is less than 0.3. They will have same answers because this is symmetrical. So 0.3 we can say is 0.6179. Let's have another example. Suppose if you want to find probability that z is less than or equal to negative 0.28. So if we make the shape of this distribution, mean is 0 and negative 0.28, and we need to find this area. So since this distribution is symmetrical, we can find this area using this table because we don't have negative values in this table. We will find this area and this area will be same as this area. So in other words, we can say the probability that z is less than negative 0.28 is same as probability that z is greater than or equal to positive 0.28. And if you want to find out probability for greater than, this table always gives the cumulative frequencies, cumulative probabilities of the same point or less. So we can say 1 minus probability that z is less than or equal to 0.28. So 1 minus probability for 0.28 is 0.2 and 8 at the top. So it's 0.6103, and when you subtract it, you get 0.3897. Let's have another example. Suppose if you want to find out the probabilities for intervals in which one value is negative and another is positive. So probability that z lies between 0.08 and 0.85. So if the variable is continuously distributed, so it doesn't make any difference if you are writing less than or equal to, is equal to. So if you want to find out this one, if we visualize the situation, mean is 0 in the center, and we have to find probability that z is between negative 0.08 and positive 0.85, and we have to find this probability. So we just can simply find probability that z is less than 0.85, less than or equal to, it doesn't make any difference. Probability that z is less than or equal to negative 0.08, as the property we learned earlier. So probability that z is less than or equal to 0.85 is 0.8023, because for 0.8 and 5 it's 0.1 minus 0.5319, because the probability of 0.08 is 0.08, that is 5319. So when you subtract them, you get 0.3342. And the situation can be in inverse situation, that we say that inverse normal distribution, in which we know the z value and we have to find the probability. The question may be that find the if z is less than or equal to a, the probability is given that is 0.6950, then what will be the value of a? So if you see in this table 6950 here, so you can say that the probability that a is less than, or probability that z is less than or equal to a is 0.69. So the value of a is 0.5 plus 0.01, that is 0.51. And let's have another example. Suppose probability that z is greater than b is 0.242, then what is the value of b? So we can say simply using the property that probability that z is less than or equal to b is 1 minus 0.242, and when we subtract it, we get 0.758. And if you look at the table above, you can see it's 0.7. So we can say that b is 0.7. So now it would of course be impractical to publish tables for a table of probabilities for every possible normal distribution, because the table that we saw earlier was for that standard normal distribution in which the mean is 0 and the standard deviation is 1. But in real life we cannot have that distribution every time in which the mean is 0 and the standard deviation is 1, and we cannot generate so many every possible normal distribution. So fortunately it is possible to transform any normal distribution to standard normal distribution. So let's begin with an example. Suppose we have a random variable x that follows normal distribution with mean 20 and variance 16, and we have to find a probability that x is less than 23. So if you visualize the situation, we have mean 20 and if variance is 16, so we can say that standard deviation is square root of 16, that is 4. And now we need to transform this normal distribution to a standard normal distribution in which the mean is 0 and standard deviation is 1. So to do this, we use the formula that if you, this is the distribution of x, and if you want to transform this to distribution of z, that follows normal distribution with mean 0 and standard deviation 1 and variance 1. So you use the formula that z equals x minus mean divided by standard deviation. So if the x value is 23 here, we need to find out the probability that x is less than or equal to 23. Suppose 23 is here, and we need to find out this probability. So if you transform, we have the x value, we have mu, we have standard deviation, just substitute the values in this formula, you will get z equals x, which is 23, minus mu, that is 20, divided by standard deviation, that is 4. So this is 3 over 4, that is 0.75. So we need to find out the probability that x is, z is 0.75 or less. If you see the table that we used earlier, in that the probability that z is less than 0.75 is 0.7734. So let's have another example. Suppose we have the same random variable x that follows normal distribution with mean 20 and variance 16, and we need to find out probability that x is greater than 14. So if you visualize the situation, we have mean 20 and standard deviation is same 4, and the probability that x is greater than or equal to 14 will look like this. We need to find out probability that x is greater than 14. So if you want, you simply use the formula that z is x minus mean divided by standard deviation. So the value of x is 14 in this case, minus mean is same 20 divided by 4. So 14 minus 20 is 6, negative 6 in fact, and when you divide it you get negative 1.5. So if this is 0, so obviously this will be negative 1.5, and you need to find out probability that z is greater than negative 1.5. So if you want to find probability that z is greater than negative 1.5, alternatively you can say probability that z is greater than negative 1.5 is 1 minus probability that z is less than 1 negative 1.5. So if you find out using the table, you get 0.9332. Let's have another example here. Suppose we have the same variable x that follows normal distribution with mean 20 and variance 16, and we need to find out probability that x is between 16 and 24.8. So if you visualize the situation, mean is 20, standard deviation is 4, and we need to find out probability that x is between 16 and 24.8. So to find out this probability, we will transform this normal variable to standard normal z. So we will use the formula that is z equals x minus mean divided by standard deviation. So z equals x is 16, because the first x value is 16, minus 20 divided by 4. So that is minus, so it's minus 1, and the other value will be 24.8 minus mean, that is 20, divided by standard deviation, that is 4. So this gives 1.2. So we need to find out probability that z lies between negative 1 and 1.2. So if you use the table or your graphical calculator, you get 0.8849 minus 0.1587. So final answer is 0.7262. So we have an examination style question here, in which the question says IQs are normally distributed with mean 100 and standard deviation 15. What proportion of the population have an IQ of at least 124? So if you visualize this situation, we have a normal distribution with mean 100 and standard deviation is 15. And we need to find out what proportion or what percentage is greater than 124. What proportion of students have IQ level greater than 124? So if you transform this into standard normal distribution, where mean is 0 and standard deviation is 1, so we have to transform this variable x that is normally distributed to standard normal variable z. So we will use the formula of transformation, that is z equals x minus mean divided by standard deviation. The value of x is 124, minus mean is 100, and if you divide that by standard deviation, that is 15, so you get 1.6. So we need to find out probability that z is greater than 1.6. So probability that z is greater than 1.6 is same as probability of 1 minus probability that z is less than 1.6. So if you use the table here, you get 1 minus 0.9452, which is 0.0548. We have another challenging question here in which the question says marks in an examination can be assumed to follow a normal distribution with mean 62 and standard deviation 16. The passing marks to be chosen so that 86% of the candidates pass. Find the passing marks. So in this situation, we know the mean, that is 62, and standard deviation is given, that is 16, and we need to find out the passing marks so that 86%, suppose this whole percentage is 86%, and we need to find out the passing marks, that is x. So in this case we know the probability and we need to find out the value of x. So if you transform this normal distribution into a standard normal distribution, so z is equal to x minus mu divided by standard deviation. So first of all we need to find out the z value, because we know the mean, we know the standard deviation, we will work for z value. If you look at the table, that the z value at which x is, if this is 86%, so obviously we know that this will be 14%, because 100 minus 86% is 14%. So the table always gives the probability that x, that z has the given value or less than that value, that is cumulative frequency less than, that is cumulative probability is less than. So we will find probability that z is less than or equal to a is 14%, that is 0.14. So if you look at the table, you get negative 1.08. So this z value will be replaced by negative 1.08 equals x minus mean, that is 62, and standard deviation is 16. So when you simplify this, that becomes 16 times negative 1.08, and the final answer will be added to 62 to get the value of x. So x equals 44. So x equals 44.72. That means the passing marks should be 44.72. So that's it for today. Thank you very much for your time.